Hello everybody, welcome to our channel. My name is Nikolay. I'm CTO of our project, and today I would like to present you the major ideas behind our Color Prism consensus protocol. We already have one video talking about this in general. I will try to discuss a little bit more in details. So the design goals of our protocol, of our consensus algorithm, is to minimize block confirmation time, to provide an algorithm that consumes little energy compared to proof of work, and support advanced governance features of 컬러플랫폼. I will talk mostly about the first 2 points. And block confirmation time is actually the key usability feature of a blockchain platform, because it specifies the time between submitting a transaction and having it mined in the block. Not just mined in the block, but mined in the block that could not be reversed. So actually this is the major business case. When you apply your transaction to the platform, you need to know how much time it will spend by the platform to file your transaction into the blockchain. And if we take, for instance, I don't know, Ethereum, it will take minutes, really, literally minutes, to wait until your transaction is mined. Other blockchains like EOS, they take less time, but they are underloaded, so we don't know how much it would be in real life. So our goal is to make it below 1 second, even into the loaded system. And the major idea behind our consensus algorithm, behind this protocol, is that if we have a look at the real-life proof-of-stake protocol, we will see that most of the time is elapsed on network communication. First, block builder needs to create a block and send it to all peers. If there are a few peers, it's very, reasonably fast. So if a block is big, like 1 megabyte, it just needs to file it to send it to some neighbors. It's one story. But if there are dozens of neighbors, dozens of other nodes that participate in validation, then sending dozens of megabytes of data might take unexpectedly long time. And another feature that we have in proof of stake is that the nodes that perform validation, they need to communicate with each other. I don't know if you can see, but there are arrows, everyone to everyone. So it is n square number of arrows, and this communication might take also very long time. The more nodes you have, the more communication it takes, and it grows like a square depending on the number of nodes, rather fast. So if we make, the more nodes we have, the more trusted our consensus is, but the more nodes we have, the more network is loaded. So this is the kind of problem that we are addressing in our design. So how do we improve network performance? The idea is that we take all the nodes that are participating in validating of blocks, and we split them into disjoint clusters, into disjoint sets that we called league. So in our system we expect to have 49 nodes split into 7 leagues. Each league consists of 7 nodes. The principle how we organize nodes into the leagues could be different, but the primary feature of the league is that in network topology, those nodes should be close to each other, so that sending between those nodes in a league could be faster than between leagues. So there is we expect that the primary criterion to group nodes will be geographical locality, like in the same country or connected by a very fast broadband trunk between them, so that the networking in the league is expected to be fast. This is init phase, a phase of network deployment, when we just create the network for our platform. The second feature is that how the networking happens when we need to distribute block. Remember that the block could be big, 1 megabyte or even more, so the less number of transmissions a single node make, the faster is all the transmission. So in our case, when a new block is being built, one of the 49 nodes becomes a primary block builder. I will tell a little more about this, but one of these 49 nodes becomes a block builder. Not only one block we select for building, but we also in every league, in each league we identify one node that becomes league leader for this particular block, for leading this block. So this league leader, one in every league, is being addressed by the central, by the primary block builder, who sends the new block to only to them, not directly to every node, not to 48 recipients, but to 6 of them. And then each league receives the block from its leader. So the second step is that the network, due to its locality, here is expected to be much faster. So here is the second transfer of 6 nodes to 6 nodes. So if this is done in sequential manner, like this node sends 1 by 1, and this also sends 1 by 1, so it is like 12 transfer, not 48, 12. So it is 4 times faster. In reality, this could be different. If the node has multiple network connections, it can send some blocks in parallel, but still we expect 2 to 3 times gain just due to this clustering. So we cluster the nodes into some leagues due to faster networking. And then BFT comes. So we also use clustering for BFT. We plan to implement just traditional practical BFT algorithm, no special new invention. The new feature is that BFT happens within leagues, so every league comes to its own consensus, either accept block or reject block. And on the step 3, block leaders communicate between each other and make the general consensus. So every block here, every node in this group of leaders, including primary block builder, who is the leader of its own cluster, they exchange the opinion of their league and make a common decision, whether accept or not. And after this consensus is found, then the leader communicates to all of the other nodes in the league, saying that the total decision is like this. Sure, there are some issues with this design or related to BFT, so there are new challenges to BFT, but we are going to solve them using validation techniques. Like the node here may be cheating, and after, for instance, the total decision is to reject, he translates to his fellows like the node was accepted. But to do this, he must provide the proof signed by all the leaders And if there is no such proof, because the total consensus was rejected, then nodes should say, no, you are cheating. You are not the true leader. We should revoke you. And it is being evicted from the league, from the set, and a new node elected for participating in this league. So we have an estimation